Now we'll see that Young's double slit experiment is a very important 5 mark question. Okay. It is used to find out that the interference concept to find that the point will be brightness or darkness. Okay, by the application of interference of light. Okay. First we see the diagram. Named here S1 and S2 are double slits to producing a coherent sources of the light. Okay, D is the small d is the distance between the two slits. Okay, its value is 0.3 millimeter. 0.3 millimeter. Okay, then this is a slit, double slit. This is a screen you have to place here with the distance of capital D is equal to 1 meter. Okay, small d is the distance between the two slits. Capital D is distance between slit to the screen. Okay, and C is the point at the center of the slit. O is the point center of the screen. Okay, suppose the two slits are producing a coherent source of light. Okay, so that the wave will meet at a point here. See the point here P. Okay, so the two source of the light here producing a wave at a point P here. It is called interference. Okay, so the point P will be maximum in intensity. That is called constructive interference or brightness. Okay, or the P may be that destructive interference or darkness. Okay, or minimum intensity. Okay, so we will see that what is the condition for that. No, okay. If the wave of the first wave starting from S1 to reach this point P here. Okay, similarly for the second wave, if it is starting at a point here, for example, I draw that on perpendicular line to that S2P. Okay, so name as a M at the point here. This is a perpendicular line. Okay, if the second wave at S2, suppose it's starting from M to P. The same time the first wave starting from S1 to P means both the waves are making parallel lines. It won't be at a point here, so there is no interference, there is no better darkness of the fringes. Okay, so that we have to make the change in the path difference. Okay, so the path difference only producing at interference at a point here, which means both the waves are made at a point at P. Okay, so the path difference symbol is del, it's meaning of S2M. Okay, so we have to find out the path difference, then only the two waves can meet at a point at P here. It's producing at interference is going to be constructive or destructive. Okay, so here say angle theta, the same angle of the C here also angle theta. Okay, so up to point P from O, you can say this is a y is the distance. It's called displacement. This point may be brightness or darkness. Let's see what is the condition for that. Okay, first I write the points here. S1 and S2 are double slit, is producing a coherent sources of light. Second, D is the small d is the distance between the two slits. The length is 0.3 millimeter. The capital D is what? The distance between the slit to the screen is value equal to 1 meter. Okay, now the path difference of S2M only is important or reason for that. The two waves are made at a point P, which makes the interference. Okay, so the path difference del you have to find it. The path difference del delta starting del between the two slits S1 and S2 is no. So what is the length we have shown here? S2M. Well, the length of S2M is equal to the full length what? S2P minus of MP. So S2P minus MP, it become S2M. Okay, so let us del equal to S2P minus of MP or S1P, both are same only. Same S1P equal to MP, both are same. So you put S1P first. Okay, now we have to draw the perpendicular line. Line that is S1M to perpendicular to S2P. Okay, so we write the diagram, S1P is equal to MP. S1P is equal to MP. So we write as S1P equal to MP. Then delta is equal to S2P minus S1P, we write as MP. Okay. So what is the value? S2P minus MP, it become S2M. Okay, so the part difference is this length only. Okay, that is a S2M. Say the delta is the similar part difference. Put the equation number 1. Okay, next we have to find out the formula for the del. We have to find it this length S2M. Okay, from the geometry of the triangles like OCP and S2, S1M, these two triangles are there, no? So from the geometry of two triangles are OCP and S2, S1M. Triangle S2, S1M. So what is the angle here? Theta, no? Or equal to theta. So we write as the two diagram. This point is S2, this is S1, here is M, here is the angle. Okay, so we want to find out this length, no? So make it a sin theta here. What is sin theta formula? Here is the angle, this is the opposite side, this is the adjacent side, this is the hypotenuse side. So sin formula equal to what? Opposite side by hypotenuse. So S2M. Then hypotenuse equal to S1, S2. So value of S1, S2 equal to what? Say D, the distance. So we will write as S2M by D. So you want S2M only. So S2M is equal to the derivative, the multiple of sine. So you will write as S2M is equal to D sin theta. Put the equation number 2. Similarly, you have to find out this length using the formula of OCP. The triangle OCP, here is theta. Okay, we have to compare the sine with the tan theta now. Okay, so what is tan theta for this diagram? So here is theta, this is opposite side, this is adjacent side, here is hypotenuse. Tan theta equal to what? Opposite side by hypotenuse value. So OP by CP. Okay. So what is the value of OP? Is Y, capital Y. Then CP is, the tan formula is opposite side by adjacent side. CP is not CO. Okay. Tan formula is opposite side by adjacent side. So OP by CO. So CO equal to this capital D. So put capital D. Put the equation number 3. Okay. If the angles are very small, if angle theta is small, we will write as that what? Sin theta is equal to theta, and then same as tan theta also theta, because of sin 0 is meaning of approximately. Sin 0 is 0, tan 0 also 0. Okay, so if the angle is very small, means you can write as sin theta equal to theta, tan theta equal to theta. Now we have to compare the equations 2 and 3. Comparing the equations 2 and 3. Okay, so what is the del? The del equal to 2 and 3 in the first equation, because first one we have del formula. So the del equal to S2M. Okay, the S2M value equal to what? D sin theta. S2M equal to D sin theta. I will write also sin theta equal to theta equal to tan theta. So I'll change the sin theta equal to tan theta means you write as d sin, you can write as tan theta. Then small d, the value of tan theta equal to what? Y by d. Okay, so that we have to get the formula for that path difference. Del is equal to dy by d. Put the equation number 4. Okay, so this is the formula for the path difference del. Okay, using this formula only we can get it that the point P is maybe brightness or darkness. Okay, so that we will see that what is the condition for the brightness fringes or the darkness fringes. Fringes means the band of light. Okay, actually in center you always get the bright, you get the bright here. Okay, so let's see what will the point P be bright or dark. Okay, now we'll see that what is the condition for the bright fringes. So bright fringes means that is maximum in intensity, and also it is called as a constructive interference. So all are same meaning. Okay, bright fringe or maximum intensity, and also for a constructive intensity. Okay, so what's the condition means? The path difference del is equal to, it should be n lambda, and n is the number of integers, lambda is the wavelength. Okay, where n is equal to numbers only, put 0, 1, 2, etc. Okay, so here del is equal to, so what is the formula we have for the del path difference? Small d y by capital D is equal to what? N lambda. So in this relation we have to find the y value, because the y only which determines the point on the screen is maybe bright or dark. Okay, so that using this relation y is equal to n lambda, the multiple small d come with divide here, the divided capital D come with multiple here. Okay, so this is the formula for that y is the displacement in the screen equal to n lambda capital D by small d. Okay, suppose for the first y means put y1, second means y2 is like that. So we have the n number of the position means we put y of n is equal to n lambda d by small d. That equation number 5. So this is the condition for the bright fringes. Now we will see that what is the condition for that dark fringes. Condition for a dark fringe or minima or destructive. Okay, same for that bright fringe also. You know that path difference del equal to, it should be 2n minus 1 into lambda by 2. This is the condition for a dark fringes. Okay, it's not same as the formula for the bright fringes. Okay, here also whereas n equal to 0, 1, 2, etc. Okay, so now we have to get that y like that. So we write as del equal to, the path difference formula we already know, that is what, small d y by capital D is equal to 2n minus 1 into lambda by 2. In this relation what is y? So y is equal to 2n minus 1 into lambda by 2, and the multiple d small d come with divide here, the small d capital D the divide multiple here. Okay, so this is the formula. We will write as numbers alone, 2n minus 1 by 2 into lambda capital D by small d. The equation number 6. This is the condition for a dark fringes. Okay, next we have to get the equation for the bandwidth. The symbol is beta. Actually bandwidth means the difference between the two constructive bright or dark fringes. Okay, so distance also given. Distance between two consecutive bright or dark fringes. Okay, distance between the two consecutive bright or dark fringes. Actually, I told the center point will be maximum here, that is the bright fringes. If the point P considering the bright, here also bright, here also bright. Okay, already we know we get the alternative fringes like this. So next it should be what? Dark. So is the dark fringes. Next it will be a bright. Next will be dark. So like that we have the things here. Dark, next is bright, dark, bright, and dark. Here is bright. Same like that, we are also getting same thing. Bright means this is dark. Again bright. It is dark. Again bright. Again dark. Okay. So we get that the fringes like this on the screen. Bright, dark, like this alternatively. But center is always bright only. It's always bright. Okay. Now what is the bandwidth means? You know the distance between what? Two consecutive dark or bright. So this exact thing, this is called bandwidth. Okay. So this thickness is called bandwidth for all the bandwidth are equal in the fringes on the screen. Okay. So this formula is there. Write as for a bright fringes. The bright fringes, the formula beta is equal to, that is the y on the screen in the n plus 1, okay, minus of y of n. So meaning of alternative or next fringes distance. Okay, so let us, what is formula for the y? We already know. For bright fringes, y is equal to yn equal to n lambda d by small d. If n plus 1 means you also put n plus 1, n plus 1 into lambda d by small d minus of yn equal to what? Same thing, n into lambda d by d. Okay, so we have beta in the left side, right side n plus 1, the two things will common for the two, so we will multiply separately. So first we write n into lambda d by small d, put plus 1 into the numbers, the variables lambda d by d same, minus of n lambda d by d. So here the plus thing is minus thing, so cancel. So we have beta is equal to lambda d by d. Okay, so this is the formula for the bandwidth. Okay.